Okay, so we're going to start with question number 1. It said Colin guesses on 10-question quiz with 5 possible answers. What's the probability of passing? So 10 is going to be our total number. That's going to be the n value in our problem. 5 possible answers. The 5 is not one of our numbers, but what we will do is we'll use that to figure out the probability. So if there's 5 choices, that means there's a 0.2 or 20% chance of him actually getting the correct answer. So what's the probability of passing? Well, on a 10-question quiz, and 70 is our passing score, so that means 7 or more will give him a passing score. Now, when we talked about binomials, we know that more is not a possibility on doing this. So this is where we have to do a 1 minus. So we're going to do a 1 minus, and the interval form of the binomial is a CDF. So I'm just going to put CDF down there. Okay, so we have 10 total questions, a probability of 0.2. Now, to figure out the number of what we need to put in the back, we are subtracting values away from the total. So if we look from 0 to 10, we want to get 7, 8, 9, or 10. Those are the numbers that we want to keep, because those are the values that will give us passing scores. So 6 and below down to 0, those are the ones that we want to get rid of. So that means that 6 is going to be our x value, or our k value, whatever letter's there, of the number that goes in at the end of our problem, because we want to get rid of 6 and below. So 6 is going to go here. So when we put this in our calculator using the second vars and then the B in the menu, letter B in the menu is the binomial CDF, you're going to type that in and you end up getting 0.00086, etc. Now, because it's got the 6 down there and we're rounding to 4 decimal places, that rounds the 8 up to a 9, so 0.0009 will be our final answer. So please be careful. A lot of you did not round correctly on this, so you want to pay attention to that. And remember, when you get this, I think it started out as e.6 something, and then it had, sorry, 8.6 something, it said e to the -4. Remember, this is scientific notation. -4 means that you move the decimal 4 spaces to the left. The negative means you're going left because that's the negative direction. So you're going to go 4 spaces, knowing that the 8 is one of those spaces, and that's where the 3 zeros in front of it come in our problem. Okay, so this is the same type of problem. Diana knows 75% of the material, so what's the probability that she will pass? So again, we're still going to use the 6 for our n value, or sorry, not our n value, our x value, and we still have 10 questions on the quiz, but instead of using 0.2 because we're not guessing, she knows 75% of the material. So it's still going to be a 1 minus, because we're still getting rid of those numbers from 0 to 6. So CDF, 10 for our total number, but this time we're going to use 0.75 because that's the probability she gets it correct, because that's the amount of material that she knows. So then we're going to put a 6 there, so we're getting rid of all the numbers from 6 and below. So if we do this and we type it into our calculator using the binomial CDF under second vars, that's going to give us 0.7759. So she has a good chance of passing this test without guessing. He has a very low chance of passing this test if he guesses on everything. So studying does help. Okay, moving on to questions 3 and 4. This talks about a company that buys components from another store that has a manufacturer that has a 95% defect-free probability. So if it's 99% defective-free, that means there's 0.01, because it's 0.99 defect-free, so it's 0.01 for a defect in the problem. So we want to make sure that we know those two numbers, the actual value and its complement. Now, what's the likelihood of having no defects? None of them. That means all 50 of them are defect-free. So you can do this one of 2 ways. So this is an exact, so PDF. And 50 is our total number, because that's our total number of components that we bought. Now, if we're going to use the 99% defect free, if we use that probability, that means that our number down here is going to be 50, because none of them are defective, so all 50 of them are defect free. So if we use the 99% defect free, we have to use 50 here. And when we do that in our calculator, we get a 0.6050. And yes, you actually need that 0 at the end, because it says to round to 4 decimal places, so that 0 at the end is the 4th decimal place. The number after it was less than 5, so it didn't round up, but it does have to be there. Okay, now the other way you can look at this is to talk about, it says none defective. Okay, so if it's a 0.01 with a defect, we can use the same 50 numbers, our probability being 0.01 for defective, and 0 being our defect number. 0 of them are defective. So this is the same type of problem, but we're using the idea that 0 of them are defective. Okay, and that's going to give us the same answer, 0.6050. Okay. So with that in mind, the likelihood that at least 2 are defective. So if at least 2 are defective, that means 2 or more are defective. So since we're going with the defective here, we're going to use the 0.01 probability. And 2 or more means 2 all the way up to 50. So that means that 0 and 1 are the only 2 possibilities of not being defective. So we're going to do a 1 minus here. Again, it's a range, so that's a CDF problem. 50 components. We're using the defective probability, so that's 0.01, because it's asking about those being defective, so 0.01. And then we're going to use 1 because we want to get rid of 0 and 1. 2 or more are defective, so 0 and 1. So we're going to put a 1 here. And that, when we do that, that gives us the 0.0894. And that will give us our value. Okay, the last one on the binomials was number 5. It talks about Tim shooting 70% on his foul shots in basketball. If he shoots 30 foul shots, what is the probability he gets exactly 21 shots made? So exactly, anytime it says that, we know automatically that that is a PDF in our binomials, because a PDF does specifically one value. N represented by the 30 total shots, 0.7 for our probability, and 21 for our number that we want to get, 21 shots. And if we do that in the calculator, that gives us 0.1573. So that will give us our value for our exactly getting 20 shots. So he has about a 15.7% chance of getting 20 shots. But remember, binomials, we leave it in the decimal form. We don't put them in percent forms. They're going to always ask you to leave it in the decimal form, and that's what we're looking for. Okay. From there, we move on to expected value. Now, I think what happened on this one more than likely is this probability here. Expected value just means you take the probability and you multiply it by the value for each one of the probabilities. And you do that over and over again for every probability and value that you're given. Okay, so in this case, we have a value of $2,000, and we have a probability of 0.1%. Now remember, when you're talking percentage, you divide by 100 to put it into a decimal. So if I divide this by 100, that moves 2 decimal places. So I'm talking about multiplying by 0.001. The decimal was in front of the 1, and we move it 2 spaces for the 100%, so that's 0.001. Okay, the second probability value is $150 that you can win, and you have a 2% chance of winning that, so that's a 0.02% chance. Now, After those two, you don't win anything. So this third value here is actually going to be 0. And you have a 0.979. What we're going to do here is take the 1, because that's a total percentage, and subtract the 0.02 and the 0.001 to get the value of not winning anything. Now, it seems ridiculous to put it up here, but remember we said an expected value, the probabilities for each piece has to total 1. So you have to have this third piece here to show that your probability is totaling 1 and you're not missing any parts. So this gives you our total of 1 for probability. We multiply everything together and we end up getting $5. Now, some of you ended up having to get some points back on this. Dollar signs go in front of numbers. US dollar signs never go behind the number. If you're talking change, if this was in pennies or something, you would say 500 cents. Cent signs go behind the money. Dollar signs go in front, so we don't put a dollar sign in the back of the money. But don't forget, if it asks you to put it in terms of dollars, you need the dollar sign. So make sure you have it in there. Okay, 1 point for each correct answer on a test that has 5 possible answers for each question, and lose 1 point for each wrong, a half a point for each wrong answer. So the 5 possible answers here means that you have a 0.2 probability of getting a correct answer. That's at 20%. So for the wrong answer, it's 0.8%. Okay, or sorry, not 0.8%, but 80% or a 0.8 probability. So the value here is 1 point for 20% or 0.2 plus, now we are losing half a point. Losing means negative value. So this is a negative 0.5 or a negative 1/2, however you want to type it in there, times the 0.8. Okay, so you have to make sure that you put the negative in there, or else you will not get the correct answer for this. Because losing points, losing money, anything like that, it's always a negative connotation, so it's a negative value. So multiplying these together is going to give you, where did that go? Negative 0.2. Okay, so this is what we wanted to look at when we found our answer. We have a negative 0.2 value of each question. So guessing on this would not be a good thing. We want to make sure we know enough to get the right answer. Okay. Now, this question, love this question, happens every year. 100 rats weekly for 52 weeks a year. What will they budget for the next year? So these were the costs that were given to you for the rats. You have a 20% probability of paying $10 for the weekly amount, 30% chance of paying $12.50 for the rats, and a 50% chance of paying $15. So if we multiply our probabilities together with our values here, and then add those multiplications, I'm not going to write it out, I'm just going to do this. If we multiply these numbers and then add them together, that gives us an expected value of $13.25. But that is for 1 week. So that is per week. Now, budget is asking you for the year. This is why it tells you that there are 52 weeks in a year, because we have to approximate $13.25 each week for 52 weeks. So we need to multiply the $13.25 by 52 weeks a year, so that that gives us $689 for the entire year. So we need to budget about $689 for the year on rats if we work at this lab. So most of you stopped here at the $13.25, but that was per week. So you need to pay attention to what the information is saying about the year and make sure that you multiply by the 52 to get it per year. Okay, $35 is the cost of 1 year warranty to have repairs for free. 12% chance of making a repair with a cost of $140. So it's asking you if you should buy the warranty. Well, first off, just remember, if you're in a math class and you don't have to do math to get an answer on a multiple choice test, It's probably wrong. So 2 of the questions were pretty obvious. You're not going to base it on, oh, you should always buy it, or no, you should never pay for something that you should get for free, whatever. Those are pretty obvious. So it was either a yes, because the $140 was more than the 35, but there you're not doing any math. Okay, expected value. Remember, expected value. So $35 is what we're trying to look at. Is it going to be more or less than $35? So 12% of the time, you're going to have to pay $140. So 0.12 probability times $140 to pay for the cost of the repairs. Now, that means if 12% of the time you have to pay $140, that means 88% of the time, or 0.88, you pay nothing because your TV doesn't break, okay, or whatever this was. So if you are multiplying these together, that gives you an expected value of $16.80. Now, you could pay the $35, but that would be paying more than the expected value of what would happen. So more than likely, you're not going to need the $35 warranty because you're probably not going to have to pay for repairs on your TV. Some people don't want to risk it, so they pay it. But mathematically, this does not make sense. The cost of the warranty is more than the expected value of what you would get on the repairs. So $16.80 is less than $35, so we would not want to pay for the warranty. Okay, this was the last question. Talked about a game, the card game. You have to pay $4 to play the game, and you can win $5 for a number card or $6 for an ace. So if you win $5 for a number card, we have to figure out how many number cards out of the 52 cards in a deck. So in each suit, you have 2 through 10 in your number cards. So that is 9 cards in each of the 4 suits. So if we multiply the 9 cards times 4 suits, that gives us a total of 36 cards that we could win $5 with. So we're going to put 36 out of 52. Okay, we could win $6 for an ace. So we put $6 here for our value. And there are 1 ace for each of the suits. That's 4 total aces in the deck out of 52. And then the last part is we don't win anything, and that would be the remaining 12 cards. Those would be the face cards, the 12 face cards. We don't win anything with those out of 52. So those are our probabilities. Now, when we do this, where you're talking about the total amount that you win, you're not putting into effect yet the $4 that you have to pay. So we haven't talked about that $4 yet. So if this game was free and you just won money for playing, you would end up having $3.92 for your expected value. But since you have to pay $4, we have to subtract that expense out of what we could consider the expected value. So $3.92 minus the $4 payment would leave us with a net loss of negative 0.08. So we would lose 8 cents for this game. Now, that's one way to do this, as to look at the total winnings before you subtract out your payment. The other way you could do this is you would go ahead and subtract the payment, and it's called net profit. Okay, the net profit would be, I don't know if that's how you spell it, 4 away from the 5, so you could win a net profit of $1 for 36 of the cards out of the 52, plus you could win $2, because 6 minus 4 is 2, for 4 of the cards out of the 52. And here you would just lose your $4, so you would have a negative 4 there because you're losing your $4 for these 12. You wouldn't win anything. Sorry, that should be 52. You wouldn't win anything, so you would just lose the $4 you pay. So this is the net profit, a negative 4 for losing the money and not earning anything. You could earn $2 or $1 above what you had to pay. So if you do it this way, where you're talking net profit, when you do the multiplication, you end up with negative 0.08 without doing any subtraction at the end. So again, you can look at it by the winnings, or you can go ahead and do net profit and do that subtraction of the $4 first. Here, this $4 is subtracted from the expected value. Okay, that is the quiz. Hopefully this will help you on your test that you have to take.